Okay, let's look at power. And I'm just going to come right out and tell you what power. You know that power is energy, how much energy we do per unit of time. Okay? Now, in electricity, we know that energy is equal to Q times that potential difference, V. All right? Divided by T, divided by time. Let's slide this time out and we get Q over T times V. Well, what's Q over T? That's I. All right? That's the amps. So power is equal to IV. But wait, there's more. This is like Ginsu knives, right? We also know from Ohm's law that V is equal to IR. So if we do power is I times V, let's take out this V and put in this IR, and I know that power is equal to I squared times R. Okay? Or I also know that power is equal to, I know that I is equal to V over R. So I can put that in where I've got power is equal to, so if I know power is equal to IV, but I know that I is V over R, I can go, okay, well, V over R times V, and so that gives me V squared over R. So my three power equations are IV, I squared R, V squared over R. Now, what normally doesn't change in power problems is resistance remains constant for the most part. But we just did a whole thing on where resistance goes up and down, fluctuates with temperature. Resistance remains constant. So, all right, so power is equal to, now, what are you buying from the electric company? You're buying energy. You're buying energy from the electric company because, why? You're buying kilowatt hours, which is a power. This is power, which is energy per time times time. Did I say you're buying power? You're buying energy. So the times cancel. So you are buying energy from the electric company. All right. That's it on power. That's basically it. All right. So, a simple one, let's say you've got V, you're running 120 volt direct, you got a direct current coming out. Actually, it's an AC current, but you've got these little rectifiers on your appliances that turn it into a direct current type thing. So you got voltages of 120 volts. And let's say you got a hair dryer that's registered at hair dryer as a power, is at 1200 watts or 1.2 kilowatts. Okay, so that's 120. That's 1200 watts of power. How many amps does it pull? Well, that's easy. 1200 equals I times 120, which would be I is equal to 10 amps. That's a lot of amps. I mean, your house can only handle 15. So that's why hair dry, kind of pull some amperage there. All right. That probably wasn't a good example. But what's the resistance? Well, the resistance, first of all, I know the V equals IR. I can do it that way. So I got 120 is equal to 10 times R. So the resistance is 12. Well, I know that's crazy. That's a made-up problem, so that's a bad problem. But you see the algebra, and it works that way. All right, so I'm going to make one more video. I want to read that one problem where you've got the like dryer that works at an optimal thing or whatever. Well, let me just read it to you so you can see what the heck I'm talking about here, Woo. All right, is it this one? And the reason I like this one's a great problem. The reason I like this one is this, I hope it's it. An ohmic appliance, okay, is rated at 110 watts when it is connected to a 120 volt source. If the power company cuts the voltage by 10% to conserve energy, what is the current in the okay? What is the power consumed? So that's all relatively easy. There's nothing there. I mean, they cut the voltage by 10%, so your voltage out of the house is going to be what, 108 now. Okay, but so that wasn't the problem I'm looking for. So again, Riggs is stumbling around looking for the frickin' problem he wants to teach you all about. Okay, this is pretty. Okay, assuming 90%. So let's take a look. How long will the water take to heat a 48-gallon tank? I love this problem. All right, so I got a 5,500 watt water heater operates at 240 volts, which is going to be the case. Even though I keep telling you that 120 volts comes out of the house, actually there's two power sources in your house. There's the 241 and the 121. The 241 has the funny looking plug, and the 241 is for refrigerators, ovens, dishwashers, maybe dishwashers. I think dishwashers, anything that has kind of, and washers and dryers, of course, okay, and water heaters, and the water heater for your shower. Assuming 90% efficiency, so that means it only operates, it's 90% efficient, it's 5,500 kilowatts, but it's going to be at 90% of that. How long will it take to do a 48-gallon tank of water? I want to play with this for a minute, and then we'll finish it.